All right, we are going to do 9-7. So you can go ahead and do the warm-up on your own. Make sure if there's an equal sign that you're solving. If there's not an equal sign, you just need to do the question. We are into our last type of new factoring, and that's going to be the difference of squares. We actually talked about the difference of perfect squares when we foiled, so hopefully some of it looks familiar. So last chapter, this is what we had, things that looked like this. So if you FOIL this, n times n is n squared, n times -5 is -5n, 5 times n is a positive 5n, 5 times -5 is -25. N squared drops, the -5n plus 5n cancels, and you have a -25. Okay, so that's your answer. So this is what we call the difference of perfect squares. Okay, difference of perfect squares. Because if you look, we had matching numbers with opposite signs to start with. N plus 5 and an n minus 5, those are called conjugates. Okay, matching numbers, n and 5 and n and 5, but opposite signs are conjugates. When you FOIL conjugates, you end up with no middle term because the -5n and the positive 5n cancel. Also, you end up with two perfect squares because you end up multiplying your firsts, which were the exact same number. N times n is n squared, that's a perfect square. And your last 5 times 5 is 25, that's also a perfect square. So since the numbers are exactly the same, you have a perfect square first and a perfect square second. You do not have a middle term at all, and you will always have a subtraction sign in between because in order for your middle terms to cancel, you needed one of each, a positive and a negative, so that last sign will always be negative, okay? So that's a difference of perfect squares. So now we just have to go from the difference of perfect squares into the factored form with the parentheses, okay? Not difficult to do, but sometimes hard for people to recognize. So the difference of perfect squares, when you have two perfect squares and a subtraction sign in the middle, okay, so a squared minus b squared. And the way that that gets factored is you have to recognize it. You have to say, okay, I only have two terms. A squared is a perfect square. B squared is a perfect square, and there's a subtraction sign in the middle. So I put my two sets of parentheses, and all you have to do is take the square root of each term. So the square root of a squared is a, that goes in the front. The square root of b squared is b, that goes in the back. And your signs have to be opposite because the only way to have those middle terms cancel is for them to have different signs. They have to be conjugates. And that would be it. So you recognize it, you write your two parentheses, you take the square root of the first term and put it in the front. You take the square root of the second term and put it in the back. And then your signs have to be opposite, and then that's how they turn into a plus b and an a minus b. So, you see two terms. Always check for a common factor first. Is there anything we can take out of an x squared and a 49? No, they don't have anything in common. But x squared is a perfect square, 49 is a perfect square, and there's the subtraction sign in the middle. So they are the difference of perfect squares. So you put two sets of parentheses and you take the square root of each. So the square root of x squared is x, that goes in the front. The square root of 49 is 7, that goes in the back. And then one of each sign. And it doesn't matter obviously where they go because the 7s are the same number. Okay, 9 and 25, is there anything we could take out of 9 and 25? No, but 9y squared is a perfect square, 25 is a perfect square, and there's a subtraction sign in the middle. So we do two sets of parentheses, square root of each. So the square root of 9y squared is 3y. So that goes in the front of both parentheses. The square root of 25 is 5. That goes in the back of both parentheses. And your signs just have to be opposite. And that's it. 16 and 9 don't have any common factors either. But 16x squared is a perfect square. 9y squared is a perfect square, and there's that subtraction in the middle. So 2 sets of parentheses. Square root of each. So the square root of 16x squared is 4x. You just split it up perfectly. And the square root of 9y squared is 3y. And then your signs are opposite. That's it, one of each. X squared and 81 don't have anything in common, but they are perfect squares. But there is an addition sign in between, and so that doesn't work. This is prime, okay? For prime perfect squares, all you got to do is circle the addition sign in the middle to let me know that that's why it's prime, because we're not making any lists of factors or anything like that. So just prime. All right, so before you want to factor anything, you always want to check for a greatest common factor and make our lives easier. So this is going to be what we call factoring completely. Make sure you do everything you can do, just keep going. So I only have 2 terms. So if I only have 2 terms, my options are greatest common factor or the difference of perfect squares, okay? So 48 and 12 have a common factor of 12. Okay, this has 3 A's that it could give me. This has 1, so I can take out 1. So I'm going to take out a single A, then put a parenthesis and take it out. So 48 divided by 12 is 4. I used to have 3 A's. I took 1 of them away, so I have 2 left. Drop your subtraction sign. 12 divided by 12 is 1. I had an A, but I took it out, so no more A's. Now, the fact that what I have in my parentheses, I still have an A squared, kind of makes me look back at it. So if I still have an exponent in my parentheses, I always need to check and make sure there's nothing else I can do. So the 12A is already on the outside, that's done and gone. But inside my parentheses, I have a 4A squared minus 1. 4A squared is a perfect square. 1 is a perfect square, and there's that subtraction sign in the middle. So that's the difference of perfect squares. So now I need to put 2 sets of parentheses and take the square root of each. So the square root of 4A squared is 2A. The square root of 1 is 1, right? 1 times 1 is 1. Your signs need to be opposite. You took the 12 out, or 12A out at the beginning, so that's still in the front of it all. And now that's your final answer. So always check for common factors first, and then if you still have exponents inside your parentheses, you always check to see if there's anything else you can do. So let's do this one. 2 terms, look for a common factor. 50 and 18, my common factor is just going to be 2. My first term has 2 x's, but my second term doesn't have any, so I can't take out any x's, so I'm just going to factor out a 2. 50 divided by 2 is 25. And then I have an x squared minus 18 divided by 2, which is 9. No x's, it didn't have any. I still see that this is being raised to a power, so I keep looking for something to do. 25x squared is a perfect square, 9 is a perfect square, and there's a subtraction sign in between, so I need to do my difference of perfect squares. The square root of 25x squared is 5x. The square root of 9 is 3. Now I need opposite signs. And I had a 2 that I brought out at the beginning, so that's still out in front of everything. And then that's it. Oops, sorry. That's it. All right, this one is a little different, so it's okay. 27 and 12 have a common factor of 3. This has 4 x's and this has 2. So I can take out as many as the littlest one has to give me, which would be 2. So I can take out an x squared. 27 divided by 3 is 9. I used to have 4 x's. I took 2 of them out, so I still have 2. Minus 12x squared. And then divided by 3. So 12 divided by 3 is 4. I used to have 2 x's. I took 2 out, so I don't have any left. I still have an exponent in my parentheses, which makes me keep looking. 9 and 4 are both perfect squares, so I put my 2 parentheses. The square root of 9x squared is 3x. The square root of 4 is 2, and my signs are different. I took a 3x squared out at the beginning, so it's still out in front of everything else. Okay, last one. 20 and 5 have a common factor of 5. My first term has 2 x's, but my second term doesn't have any. 20x squared divided by 5 is 4x squared minus 5 divided by 5, which is 1. Do not lose the fact that 1 is a perfect square. A lot of people forget about that. So I still have a square in here, so I keep looking. 4x squared and 1 are both perfect squares, and there's a subtraction in between. The square root of 4x squared is 2x. The square root of 1 is 1. My signs are opposite. I took a 5 out at the beginning, so it's still in front. Okay, we'll do this one. This one has a lot going on, so you gotta pay attention. All right, 2 and 162 have a common factor of 2. My first term has 4 x's, but my second term doesn't have any, so I can't take any out. So that leaves me with a 1, x to the 4th, minus 162 divided by 2. 162 divided by 2 is 81. All right, now I look in here because I still have an exponent on my variable. So I keep looking. If that exponent is even, so far we've had x squareds, and so we know that's a perfect square. Now I've got an x to the 4th. The fact that 4 is even makes it a perfect square, because with exponents, you just have to be able to split them up evenly. You gotta split them into 2 pieces for it to be perfect. So I do have a difference of perfect squares here. So the square root of 1x to the 4th is 1x squared. 1x squared in both, because you just split that 4 into 2 pieces. The square root of 81 is 9, and your signs are opposite. And we took a 2 out at the beginning. Now, hold off, because I still have exponents in my parentheses, so I need to keep looking, okay? Just to make sure. 1x squared is a perfect square. 9 is a perfect square. This one has an addition sign in it, so I cannot do anything further to that. That one's going to have to stay as is. This second one has a subtraction sign in it, so that is the difference of perfect squares again, so I can do it again. So that one I'm going to split, and the square root of 1x squared is just 1x. In the front, the square root of 9 is 3, and my signs will be opposite. This set of parentheses I couldn't do anything with because of the addition sign, so it stays. And at the very start, I took the 2 out. So this whole thing is my answer. Okay, a lot going on. But if there are still exponents left in your parentheses, you got to keep going or look for something. Okay, so like I still have an exponent here, but that's not the difference of perfect squares, so there's nothing else I could do. But I just have to be aware that there's a possibility that it can keep going if there's still an exponent. Okay. All right, we'll do this one. You can skip that other one. There's an equal sign, so before we do anything, it has to be set equal to 0, okay? And so we want my square term to be positive, which it is. So I have to subtract the 25 over. So 4y squared minus 25 equals 0. I got to factor the left. 4y squared is a perfect square. 25 is a perfect square, and there's a subtraction sign in the middle. So I put my two sets of parentheses and take the square root of each. Square root of 4y squared is 2y. The square root of 25 is 5. My signs will be opposite. I am not done because I have an equal 0, so I need actual answers. So if I take this first set of parentheses, 2y plus 5 equals 0, subtract the 5, so 2y equals negative 5, divide by 2, which is not evenly divisible, so I'll just leave it, negative 5 over 2. I have to do it again for my second set of parentheses, so 2y minus 5 equals 0. Add the 5 this time, so it's a positive 5, divide by 2, positive 5 halves. When you're solving for conjugates, you have the same numbers and opposite signs. So the fancy way to write your answer is just y equals plus or minus 5 over 2. That means positive 5 halves and negative 5 halves. So you really don't need to solve it twice because you know you're going to get the exact same answer with different signs. So you can just jump straight down and tell me plus or minus 5 halves if you want. Or you can write them separately and that's fine too. Okay, don't worry about this one. Don't do it. It's a bad question. Don't worry about these. We've already done enough. All right, 9-7.